Welcome to the deep dive. You're here because, well, you want to get smart about things quickly, right? Cut through all the noise.
Exactly. No endless scrolling.
We do the heavy lifting, you get the insights. Today, we're diving into a really fascinating chat with James Cameron.
Yeah, from the Boss to the Future podcast. We listened to his conversation with Boss, and honestly, there were so many nuggets in there.
Totally. We've basically distilled it down to the core ideas, the stuff we think will give you those real aha moments.
Right. Things that connect technology, storytelling, maybe even things you didn't expect.
For sure. I mean, everyone knows him for the movies, right? Titanic, Avatar, Terminator, a master storyteller. But this conversation, it goes deeper.
Much deeper. He's been to the Titanic wreck, what, 33 times?
33? And the Mariana Trench, the deepest point on Earth, he went there himself.
Incredible. But the thing that really jumped out at me, beyond the films and the deep sea stuff,
Let me guess. The farming.
the farming.
Yeah.
He's not just dabbling. He's seriously into organic farming and technology innovation, obviously, but the farming was a curveball.
It really was. So that's our mission for this deep dive. Connect the dots. Technology, storytelling, even agriculture. How does someone like Cameron see these things intersecting?
Let's pull out those key insights, yeah. Where should we start? Maybe with the farming, since it's so unexpected.
Good call. Okay, so what's the deal with his farming? It's not just a hobby, is it?
No, not at all. He calls it investigative farming. It's all organic, focused on, like, new agronomy, different crop rotations.
Investigative farming. I like that. What's driving it?
A big part is his concern about something called peak phosphorus.
Peak phosphorus, like peak oil, but for fertilizer.
Essentially, yeah. Phosphorus is crucial for synthetic fertilizers, but it's a finite resource.
Right.
And getting it, processing it, shipping it, it has this huge carbon footprint.
Ah, okay. So his organic methods are about getting away from that dependency, building up the soil naturally.
Exactly. Replenishing nutrients, reducing the need for these long, high-carbon supply chains for synthetics.
It actually reminds me, my family has a bit of farming background. We had a horse ranch, then a vineyard, but way back, apricots, prunes, classic California stuff.
Oh, wow.
And we still have an alfalfa ranch. My cousin runs it now. And he's actually working on developing a new strain of alfalfa that needs less fertilizer.
No kidding. See, it connects. Small world. And Cameron actually mentioned alfalfa specifically.
Really? What is that?
He talked about its root system. Apparently, alfalfa roots can go down. Get this. 40 feet.
40 feet. Seriously, that deep.
Yeah, it's wild. And because they go so deep, they tap into what he called paleonutrients.
Paleonutrients? Like nutrients from way back?
Kind of minerals deep down that haven't been touched or depleted by shallower rooted crops, like wheat or corn.
Okay, that makes sense. So it's accessing this whole other layer of soil nutrition.
Right. And then he talked about using that nutrient-rich alfalfa in green compost for growing vegetables.
Yeah.
It creates this really efficient sort of closed-loop system.
Wow. So even with farming, he's thinking about systems, innovation, sustainability. It's not just planting seeds.
Definitely not. It's applying that engineering mindset to the earth.
Okay, cool. So let's shift from literal Earth to the cinematic world. 3D, he's obviously been a huge pioneer there.
Oh, absolutely. A lifelong passion, it sounds like.
He mentioned that back around 99, 2000, when HD was starting to look like it might replace film, he saw a big problem with using film for 3D. What was the issue?
Well, think about a film camera. You've got the film itself moving through the gate, right? The film plane.
Right.
In a 3D setup, you need two of those. And the physical space needed for the film magazines and the mechanics meant you couldn't get the lenses very close together.
And why is getting the lenses close together so important for 3D?
It's about mimicking human vision. Our eyes are only a few inches apart. That interocular distance is key for how we perceive depth, especially up close. If the camera lenses are too far apart, the 3D effect feels exaggerated, unnatural, especially for close-ups. It can even be uncomfortable to watch.
So film cameras force this wide separation, making good close-up 3D really hard. These massive rigs, right?
Huge, yeah. Whereas digital cameras, well, fundamentally it's just a lens and a sensor, much smaller.
So his first thought was just, okay, put two digital sensors and lenses side by side, like robot eyes.
Pretty much.
Yeah.
Seems logical, right? But then you hit another physical limit. The lenses themselves have physical size, the sensors have physical size.
You still can't get them close enough for those really tight shots.
Exactly. You can't make the interaxial distance, the space between the lens centers, small enough for convincing close-ups without the lenses literally bumping into each other.
Okay, so side by side wasn't the perfect solution either. What did he realize he needed?
He had to dive into the optics, the stereoscopic principles. And the key was the beam splitter.
A beam splitter. How does that work? Sounds complex.
It's actually pretty clever. It's basically a partially reflective mirror placed at an angle. One camera looks straight through it at the scene.
Okay.
The other camera is positioned off to the side, and it sees the scene reflected off the surface of that beam splitter.
Ah, so it's like one camera's view is folded, allowing the lenses to effectively overlap in space, even though they're
Yeah.
physically separate.
You got it.
Yeah.
That lets you shrink that interaxial distance way down, making those cinematic close-ups in 3D possible and comfortable for the viewer.
That makes sense. He mentioned making a 3D film for Universal T23D way back.
Oh yeah, with cameras the size of refrigerators. That was before his digital beam splitter system. It really shows how far the tech had to come.
And a big driver for him developing his own digital 3D camera system wasn't just the tech challenge, it was a specific goal, right? Something about the Titanic.
Yes, he wanted to go back and film the Titanic wreck, but in 3D.
Not just look out a window, but actually film it cinematically.
Exactly. He envisioned getting real shots down there, panning, tilting, moving the camera like you would on a movie set. But, at 12,000 feet underwater.
In 3D.
In 3D. So he needed a compact digital 3D camera using that beam splitter design inside a housing that could withstand insane pressure.
And it needed pan and tilt capabilities inside that housing.
Right. An incredible engineering challenge. But it was that artistic goal, filming the Titanic in 3D, that gave him the deadline and the motivation to actually build it.
That's a recurring theme, isn't it? The artistic vision driving the technological leap.
Absolutely. It wasn't just tech for tech's sake.
And that drive put him ahead of the curve elsewhere, too. Let's talk digital cinema. Early 2000s, theaters weren't exactly rushing to switch from film projectors, were they?
No, definitely not.
Yeah.
Think about it from their perspective. They had huge investments in 35mm projectors that worked perfectly well.
Why spend a fortune on new digital projectors if the audience is paying the same price for a ticket? What's the added value?
That was the question. There wasn't an obvious benefit for the moviegoer initially.
But Cameron saw the potential. He got involved early with Texas Instruments, right? With their projection chip technology.
Yeah, he connected with Doug Darrow at TI,
Yeah.
who was really key in developing the DLP chip, the mirror chip tech that's in most digital projectors now.
And Cameron's input wasn't just about making digital projection happen. It was about making it 3D ready from the start.
That was his crucial insight. He pushed them to make sure the whole system, the chip, the servers, everything, could handle the high frame rates needed for good 3D using multi-flash technology. He saw 3D as the killer app for digital.
And that's what broke the dam, basically.
Pretty much.
Because suddenly, theaters could offer something extra, an immersive 3D experience.
And charge more for it. That created the business case. Now there was a reason for exhibitors to invest.
Right. And studios benefited too, didn't they?
Yeah.
Digital delivery versus shipping heavy film cans?
Oh, massively. Instead of weeks of printing and shipping physical reels, hoping they arrive on time without damage.
Nightmares, I bet.
They could just send encrypted digital files, like the day before release. Huge cost savings, much more secure. So 3D really greased the wheels for the entire digital cinema transition.
It's amazing how one technology can pull a whole industry forward. Okay, speaking of pulling things forward, Avatar. The ultimate example, maybe. He first had the idea in 1995.
Yeah, way back then.
Yeah.
But he knew, even as he was conceiving it, that the tech just wasn't there yet.
What was missing? I mean, CG was advancing. He mentions things like the water tentacle in the abyss, the T-1000.
Right, those were big steps. And he'd co-founded Digital Domain, which is a huge move, the first all-digital effects house.
Yeah.
He was betting big on CG.
But still not enough for Avatar. Why not?
Because Avatar wasn't just adding a few CG elements into a live-action plate. Almost every shot required complex digital creation.
The Na'vi characters, Pandora itself.
Everything. The environments, the creatures, the vehicles. And crucially, the main characters needed to deliver nuanced emotional performances. Things like believable muscle movement, realistic skin, and especially capturing the actors' facial performances convincingly. That just wasn't possible in '95.
So when he pitched it, the reaction was...
Basically, we can't do this. Or, as he put it, maybe they could try, but they'd go bankrupt in the process.
Huh. Okay, so he put it on the shelf for 10 years. What brought it back? What changed?
The big moment was seeing Gollum in the second Lord of the Rings movie.
Ah, the performance capture.
Exactly. Seeing that level of performance-based CG, how Gollum could emote and interact believably, that convinced Cameron that tech had finally caught up enough to make Avatar feasible.
So he dusted off the scriptment.
Yep. assembled a team, worked with Weta Digital, ILM, and they essentially had to invent a lot of the pipeline as they went,
Yeah.
especially that image-based facial performance capture system.
The one that maps the actor's face onto the digital character?
Right. That was a huge development, driven specifically by the needs of Avatar, and now it's pretty standard. Again, the story demanded the tech.
Incredible. Okay, fast forward again. Now we have another wave. AI in visual effects. And Cameron's involved again. He's on the board of Stability AI.
Yeah, which is interesting. He acknowledges he had initial concerns about AI, particularly certain military applications, but he sees massive potential now for VFX.
To do what exactly? Make movies cheaper.
That's part of it. His stated goal is pretty ambitious. Cut the cost of big, effects-heavy films in half.
Wow, by replacing artists with AI. That's the fear, isn't it?
Well, that's the crucial point. He says his goal isn't layoffs. It's about doubling the speed and productivity of the artists.
Augmenting them, not replacing them, making them more efficient.
Exactly. Letting them do more creatively, iterate faster, maybe tackle things that were previously too complex or time-consuming. He contrasts traditional CG, which evolves kind of slowly now, with generative AI's potential, even though they don't perfectly mesh yet.
So where does he see AI fitting in? What kind of tasks?
He's focused on the intersections, things that are currently very labor-intensive and maybe less creatively fulfilling for the artists themselves.
Like what?
Rotoscoping, manually tracing around objects frame by frame, motion editing, outpainting, which is extending an image beyond its borders, upscaling resolutions, tasks that AI is getting pretty good at.
Right, the grunt work, almost.
Kind of. And he made this interesting analogy. He said his own directing workflow is already a bit LLM-like.
How so?
He gives very specific prompts, detailed instructions to his large team of artists. He sees AI as a tool that can help those artists execute those prompts more effectively, automating some bits, freeing them up for the artistry.
That makes sense. But this whole AI thing in Hollywood, it's sparking huge debates, right? Copyright, training data.
Oh yeah, big time. There's a lot of anxiety about how these models are trained, what happens to existing libraries of work, who owns what.
What's Cameron's take on that side of it, the legal and ethical stuff?
He has a pretty provocative viewpoint. He basically says we are all models, meaning we all learn and create based on everything we've ever seen, heard, experienced. Our training data is our entire life. He thinks the legal focus should be on the output.
Is the final image or text clearly plagiarism? Does it directly copy something protected?
Exactly. Rather than trying to control the input, the vast, messy, uncontrollable data the AI learns from, he argues artists naturally filter influences anyway to make something new.
And he worries that focusing too much on the training data could stifle creativity, especially for newer artists.
Yeah, that it could lock things down, favor those with huge existing libraries. He did suggest maybe discouraging prompts like, make it in the style of James Cameron.
Right, don't just copy a style directly.
But acknowledges that internalizing influences is just part of how people create.
Right.
He compared it to fan art.
Fan art is generally okay unless someone starts selling unlicensed t-shirts or something that directly harms the original creator's market.
Precisely. The line is commercial exploitation that causes demonstrable harm. It's a pragmatic view.
Okay, that's helpful. And just to be clear, we're mostly talking about generative AI here, right? The image generators, text generators. That's different from AGI.
Crucial distinction, yeah. Gene AI is amazing at specific tasks based on patterns in its training data, but it doesn't understand the world. It doesn't have a real-world model.
He called it a stochastic parrot, right?
Yeah.
Mimicking patterns without true comprehension.
Exactly, which is miles away from artificial general intelligence, AGI, a hypothetical AI with human-like cognitive abilities, maybe even consciousness.
Which raises the whole question, how would we even know if an AGI was conscious? The Turing test seems kind of flawed.
Yeah, Cameron basically said, as a filmmaker creating illusions, he knows humans are easily fooled. So just acting human isn't enough.
So what then? How do you measure consciousness?
It's a massive philosophical question. Maybe it's not on-off, maybe it's a spectrum, like Douglas Hofstadter suggested in I Am a Strange Loop.
Right, and we have things like the mirror test for animals. Chimps recognize themselves, dogs usually don't. Shows some self-awareness.
So what's the mirror test for AGI? What would it need to demonstrate to convince us it has genuine self-awareness, an internal model of itself and the world?
That's a big question. Like, does it have a theory of mind? Does it understand that we have thoughts and intentions separate from its own?
Exactly. These internal models are how we navigate the world. Could an AI develop that? Who knows? It's deep territory.
Definitely. Okay, shifting back to something more concrete, though still immersive. Head-mounted displays, HMDs, VR headsets. Cameron wasn't always sold on them for movies, was he?
No, he expressed skepticism about the quality for narrative experiences. But apparently, the newer generations, specifically mentioning the MetaQuest 3, have really changed his mind.
What's better about them now?
Two key things for 3D. First, they deliver a completely separate image to each eye. Discrete, left-right views.
Which gets rid of the ghosting or crosstalk you sometimes see in theaters, where one eye's image leaks into the other.
Exactly. It's a much cleaner, more comfortable 3D image. Second, and this is huge, brightness.
Ah, right. Theatrical 3D is often criticized for being too dim.
Way too dim. He quoted the SMPTE standard minimum brightness for theaters at 16-foot Lamberts. But 3D projections, because of the filters needed, often struggle to hit even 3.5-foot Lamberts.
Wow, that's less than a quarter of the minimum brightness? What does that do to the picture?
It crushes the dynamic range. Even if the blacks are okay, the highlights are so dim the whole image lacks contrast and punch. It looks dull, washed out compared to how it was mastered.
But these new HMDs can deliver full brightness to each eye.
That's what he's excited about. He said the image quality is phenomenal, comparing it very favorably to Dolby Vision laser cinema.
Which he considers the best theatrical experience right now.
Yeah, he specifically recommended Dolby Vision laser cinema for seeing films, especially his, as intended. They have really tight quality control. He mentioned IMAX digital 3D can be good too, but Dolby Vision is consistently top tier.
So for him, these new HMDs are finally delivering an image quality, especially for 3D, that lets audiences see something much closer to the filmmaker's vision, like a door opening.
That was his phrase, yeah. A real potential game changer for immersive viewing.
Okay, let's dive one last time, literally this time, into the oceans. Another of his big passions. What's the state of exploration down there? How much do we really know?
Shockingly little is the short answer.
Yeah.
He put it starkly. If you add up all the deep ocean trenches, the area is below 6,000 meters.
The really deep parts.
Yeah, the Haddle Zone. That combined area is roughly the size of the continental United States.
Wow.
And our exploration of it, he used an analogy.
Yeah.
It's like dropping into Montana at night, turning on flashlight for 3 hours, and then saying, okay, explored Montana. Point taken. So vast amounts are completely unknown. What do we expect to find down there? Giant squid, krakens?
Probably not giant monsters, unfortunately. He thinks the discoveries will be more on the microbial level. New genomes, bacteria, archaea, tiny life forms uniquely adapted to extreme pressure and darkness.
Still biologically fascinating, though. Insights into life's limits.
Absolutely. But he also stressed the importance of understanding and protecting the twilight zone. That's the layer just below where sunlight penetrates, down to maybe 1,000 feet or so.
Right. It's teeming with biomass. Maybe not huge creatures, but vast numbers of smaller fish, jellyfish, krill, and it's where the largest animal migration on Earth happens every day.
The vertical migration, what's that about?
Billions of organisms swim up towards the surface at night to feed, then sink back down into the depths during the day to avoid predators.
And that daily movement is important. Why?
It's a massive carbon pump. They eat carbon-rich stuff near the surface, then take that carbon down deep when they descend or die. It gets sequestered in the deep ocean, away from the atmosphere for potentially hundreds of thousands of years. Hugely important for climate regulation.
But this vital zone is under threat from fishing.
Increasingly so, yeah. Commercial fishing is pushing deeper, targeting these twilight zone species, often before we even understand the ecosystem fully.
And our monitoring is lagging behind.
Way behind. He contrasted it with how we monitor the atmosphere, satellites, constant data streams, AI analytics, real-time understanding. We have almost none of that for the ocean.
And funding reflects that. More money for space than the deep sea.
Significantly more, which he finds baffling given the ocean's importance to our survival. His solution?
Robots.
Lots of them, mass-produced, relatively cheap, autonomous underwater vehicles, swarms of them, with onboard AI, exploring, collecting data, surfacing to transmit it, democratizing ocean science.
Oh, compelling vision. Okay, wrapping up. As a sci-fi creator himself, what's he watching these days? Anything impress him?
He mentioned enjoying Severance, Fallout, The Last of Us, though he noted the prevalence of post-apocalyptic themes right now.
Can't argue with that.
He praised the high bar set by shows like Westworld and Foundation for ambitious, big-idea sci-fi.
But he's worried budgets might be shrinking for that kind of thing on streaming.
Yeah, a concern the streamers might lean towards safer, less expensive genres, potentially squeezing out the really high production value sci-fi epics.
Though he hopes maybe HMDs could create a new market for that kind of immersive cinematic experience.
That seemed to be his hope, yeah. And also acknowledging the listener's hope, perhaps, that AI could eventually make ambitious storytelling cheaper and faster.
Right, and that brings up the point about sci-fi often being dystopian. Why is that, do you think?
Well, he acknowledged optimistic examples,
Mm,
like The Martian is a good one,
sure.
but generally storytelling needs conflict, right? Drama. A perfectly happy utopian future.
Mm.
Well, where's the story? It's like trying to write a murder mystery where nobody dies.
Good analogy. You need stakes, challenges.
Exactly. And he pointed out sci-fi is diverse. Think about Black Mirror. It explores all sorts of anxieties and ideas, not just action and explosions,
Right. It uses the future or technology to explore the human condition, often in uncomfortable ways.
which can be incredibly valuable, even if it's dark sometimes. It makes us think.
Okay, so to wrap this deep dive up, what an incredible range. We went from organic farming and peak phosphorus.
All the way to the tech journey 3D, making Avatar happen against the odds.
His really pragmatic view on AI and visual effects augmenting artists, not just replacing them.
The complex legal stuff around AI art, his "we are all models" idea. The potential of VR headsets finally hitting their stride.
And then plunging into the deep ocean, the twilight zone, the need for robotic explorers.
It really feels like it all comes from the same place, doesn't it? That intense curiosity, the problem-solving drive, whether it's soil nutrients or digital pipelines or pressure housings.
Absolutely, that relentless push to see what's possible technologically and artistically. So maybe the final thought for you, our listener.
As you're absorbing all this, maybe consider how this evolving dance between human creativity and AI might really redefine what we even mean by art or authorship.
Or think about those vast, unexplored oceans. What does it mean that we know so little about such a critical part of our own planet? What secrets about our future might be down there?
It's all about that balance, right? Pushing technology forward, but always driven by that human vision, that need to explore and tell stories.
Definitely. And hey, if you want to see where some of this is headed, keep an eye out for Avatar 3, hopefully, in Dolby Vision Laser Cinema.
And watch what companies like Meta and others are doing with immersive tech. It feels like a lot of these threads are converging right now.
Absolutely. Well, thanks for joining us on this deep dive.
Yeah, great discussion.
Until next time, keep exploring, keep asking questions.